Okay, so the previous video, we left off right here where we were getting ready to kind of go through one full example of this process of how to create a confidence interval. And we said there were really kind of 4 steps to this. And it's not that you have to write state, plan, do, conclude, but you have to do the elements of each of these. And this is just kind of a helpful way to kind of remember all the pieces that they'll be looking for in the rubric when you design these confidence intervals. So the state portion is where you're going to name the parameter that you are estimating, and you also need to state the confidence level that you're going to be calculating. And so oftentimes it looks something like this, where you'll say something like, we're going to estimate P, which would be the true proportion of, and then you would state that in context, whatever P is representing, at a blank % confidence level. Okay? Then moving on to the plan part, there's also 2 pieces to this. I've tried to underline these really important pieces in here. The first piece is you have to name the inference method. Okay. Now for us, right now, we've only learned one method. That method is a 1 proportion z interval. That's what we're calculating. The problem we'll have referenced, there will have been 1 sample that was taken. Later, we're going to talk about when there's 2 samples. So that's why the name for this is a 1 proportion. That's what we're estimating. Z, and then interval represents confidence interval. Okay, and then you have to assess the conditions. Okay, and this is where we go down through this checklist and we make a statement and check off, yes, there was some type of random assignment or a simple random sample was taken. We check off for independence the 10% rule, and then again we check off that large counts condition was met for normality. Okay, it's not actually until you get down to the do step where you're actually performing the calculations from the formula. Okay, and please note that it says if the conditions are met. Okay, I will say though, on any free response question, the assumption is the conditions should be met. Now, that doesn't mean that you don't have to list them. You will definitely get docked points if you do not list them. But if for some reason you feel like, I don't think one of these conditions is actually met, okay, you can go ahead and make that statement up there in the condition part for the plan section, but go ahead and see the problem all the way through to the end and go ahead and do the do step and the conclude step because it's assumed that the conditions should be met for those free response questions. Okay. Now, once again, this full-blown formula is not on the formula sheet. A more generic version is, and you kind of have to put the pieces together to create this. Okay, and then lastly, the conclude part, which is what we really focused on in section 8.1, is where we go about interpreting the interval. Super important that it's always in context. Okay, generally it looks something like a statement like this. Okay, we're blank % confident that the interval we've created from blank to blank will capture the true proportion of in context. Okay, so here's the problem we're going to take a look at. Okay, it says Mrs. Quinn's class took a simple random sample of 102 pennies from a very large penny collection. She discovered that 57 of the pennies were more than 10 years old. Calculate and interpret a 99% confidence interval for the true proportion of pennies from this collection that are more than 10 years old. Okay, so when we do confidence intervals, we are making an estimate. We're trying to construct an interval with a certain level of confidence that we think will capture what that true population proportion is. Okay, so if we follow our steps above, the state portion is where we're going to make a statement such as, we're going to estimate P, the true proportion of pennies in the collection that are more than 10 years old, and we are going to estimate that, we're going to use a confidence level of 99%. Okay, so that would be the state portion. Okay, the next step, the plan step, you have to say what inference method you're going to use. Okay, I always like to call it a 1 proportion z interval because that is how it's named on the calculator. It just makes it easier that when we get down the road later and we end up using a little bit of our calculator to do this, it's in line with what we've been calling it. But you may also see it on rubrics as being called a 1 sample z interval for P. Okay. All right, so now let's go ahead and assess our conditions here. Okay, we need to check and see, was this random? And so I look back and I see it says that she took a simple random sample of 102 pennies. So I'm going to say a simple random sample of 102 pennies was taken. Okay? You can't just write random and put a check mark. I know it sounds really silly, but you've got to acknowledge with a kind of a statement there. Okay, 10%, this is our check for independence. Okay, 10 times said her simple random sample was 102. So if we take 102 times 10, that would yield 1,020. It needs to feel kind of believable that 1,020 would be less than or equal to all the pennies in the collection. Okay, and they mentioned that the collection was very large, and so we can assume it would be believable that there would be much more than just 1,020 pennies in this collection. Okay, last condition, this is for normality. This is where we take n times p. Now, they did not actually give us p in this problem, okay? But remember, p, I'm just going to write this up here, p hat is found by taking the number of successes, that would be 57 of the pennies were 10 years old, over the number in the sample, okay? So we just kind of have to calculate what the p hat value is ourselves here. Okay, it's 0.56, so we're going to multiply that by n, and we end up getting 57.12, definitely greater than or equal to 10. And then we're also going to take 102 times 1 minus p. That obviously also gives a number greater than or equal to 10. Okay, so we can check off that we've checked all the conditions and we're good there. Okay, so now we're going to move on down to the do step. Okay, the do step is where we kind of get into the actual construction of the interval itself. Okay, so the interval starts with our point estimate. Remember, our point estimate, we needed that p hat value anyhow. That's the 0.56 plus or minus. We're going to need to fill in our critical value for our z-score there. So I'm going to put parentheses. We'll go back and do that in just a second. Okay, and then the standard error, that's the square root of, it would be p hat, the 0.56, times 1 minus p hat, the 0.44, divided by n, the 102. Okay, to get our z-score, I'm looking up in the problem, I see this is a 99% confidence interval. So if I didn't have that memorized, it's no big deal. I don't think they expect you to even show what I'm writing here, this part, on the exam. But I'm going to take what's in the tail, or what's left over, divided by 2, so I get what's in the tail. That's what I'm really typing in. Remember, this is the area mean standard deviation. Okay, and that would give you that 2.58 z-score goes right in here. Okay, I'm going to go ahead and type this part in because that's going to represent the margin of error. Okay, if we type that in, that gives you, after the plus or minus, this number, and then if we go through the problem to actually create the interval, we get 0.43 to 0.69. That's the interval. Okay? Okay, so then we're down to the conclude portion, and this is where we're just kind of drafting our sentence to make a statement here about what our conclusion is. And we could say, all right, we are 99% confident that the interval from 0.43 to 0.69 captures the true proportion, here's the context part, of pennies in the collection that are more than 10 years old. Okay? There is a part B to this, and that's going to be picked up in the next video.